Hi, I'm Ernie Gillard. This summer, as part of the SURE program, I've been working with Professor Bertacco with the Semantic Guardian project. I'm a junior in computer science. So the reason we have the Semantic Guardian project is because processors are released with bugs. As you can see from these website headlines, maybe the past 10 or 15 years, processors from all different kinds of manufacturers like Intel, AMD, Sun, they're all released with some bugs. So the reason why processors are released with bugs is just because they're so big and they're so complex that there's no way to test them completely. So that's where the Semantic Guardian comes in. The Semantic Guardian, how it works is by labeling all the states that a processor could be in as either trusted or untrusted. So a trusted state is a state that we've seen before in our testing, in our simulations, and we know that it works. And an untrusted state is a state that we didn't get to yet. We don't know how it'll work. So the Semantic Guardian will monitor the processor at all times, and when it sees that it's in an untrusted state, it'll trigger the processor to go into a sort of safe mode. And once it's in the safe mode, it'll run slower. It'll run in a way that we know is going to be correct. So here's a little diagram. So here's a model of what a processor looks like, a pipeline you call it. So here we have some instructions coming through the pipeline. We have a multiply, we have an add, a store, and a load. Say for this example that we've never seen this sequence or this state of instructions in our processor before. So the Semantic Guardian will see this, and it'll trigger our processor to go into a safe mode. And once we're in safe mode, we're going to run these instructions in a way that it'll put one instruction at a time through the pipeline, and we know that they'll be correct. We know our answer will be correct in the end. So it'll send the instructions through just like this add. So just to reiterate the basics again, the Semantic Guardian is an approach to guarantee functional correctness during the runtime of the processor. So it's a way to make sure all the programs, all the operations that our processor does is correct. So first of all, we monitor the critical signals in the design. We monitor the signals that don't change very much or the signals that do change a lot. And we switch to safe mode when these signals have an untrusted configuration, a configuration that we haven't seen before. And again, the safe mode, it's formally verified, it's simpler, it's only one instruction in the pipeline at a time, so we know it's going to be correct. So specifically what I've been doing this summer is implementing the Semantic Guardian on a real processor. It's called the Leon 3 processor. It's an embedded processor. It's used in like aerospace and automotive designs. And what I've been doing is using a well-known benchmark suite called MyBench, which was developed here at U of M. And so we run all these little programs that are part of MyBench, and we run them on our processor. And that'll tell us what signals are most important, what signals we want to monitor with the Semantic Guardian. So once we have these signals monitored and we create our Semantic Guardian, another thing we have to do is actually implement the safe mode on the Leon 3. Like it's something that's not built in. And finally we're going to synthesize it and download it to an FPGA. And an FPGA is it's a way of having like a physical implementation of our design. And here's a picture of a common FPGA chip. So that was my project in general. My SURE experience overall, it's been really good. I recommend it to any undergrad who's thinking about research or grad school. And some of the cool things about the SURE experience are you get to work every day with grad students and professors, something you just don't get in the classroom. You get research experience, and you get to see what grad school is like if you do plan on going there. And most importantly, you get to work and solve problems independently without always being told exactly how to solve a problem. You have to solve it yourself. So that has been my presentation. Thanks for watching.